Okay, in this video, I'm going to talk about how to machine out a couple of the C channels, one for the front and one for the back. I'm just using the same C channel for the front and the back. This will work even if they're different. The first thing you should do is make an assembly such that the dimension between one face and the other face is 2 inches. As I talked about in class, I designed my pieces for this distance to be 0.875, which allowed a distance of 1/4 of an inch between the two pieces, so I could use a 1/4 inch end mill to cut those pieces apart. So in the setup, let's do this face first. And so I'm going to go to setup, and here, the first thing I'm going to do is just go select my work coordinate system here. Going through this fairly quickly since we did this in the previous part. So we have the work coordinate system here. One thing you want to do if you have an assembly is tell the computer what are the models, since they're more than one piece. Sometimes it might think those pieces are fixtures. They're not, they're actually part of the model. There are no fixtures here, so you can skip over that. Under stock, you can choose however you'd like to do that. I'm just going to go a relative size box with no extra material. Hitting OK. Now my setup is there. I'm going to call this setup 1. And really, I'm going to call it setup 1 and 3 because the opposite side is the same since these two parts are the same. So if I were doing this opposite side, it would really be the same G code. So I'm just going to call it setup 1 and 3. First thing I'm going to do is drill, select the tool. For that, it would be the 0.196 end mill. So I'm going to select the geometry. I want everything the same diameter and only the same Z height. Going to the depths, I do want to drill through the bottom, and I want to go an extra depth, maybe 50 thousandths. You could verify that. Again, going through this quick since I did the same thing in the previous video. Once that's done, now I just need to do the end cut. So I can do a 2D contour, select the tool, which would be a 1/4 inch end mill. The geometry, which would be this here. One thing that I skipped over is I do want to slow down the feed rate since this is a slot cut to something half or less than half of the default feed rate. Then finally is, I got to do the depth. I'm going to go an extra 25,000, so I'm going to go negative 0.15. And then the final thing, the lead-in sweep angle is 0, and linear lead-in distance is something larger than the radius of the end mill. Double checking, making sure we're not diving into any material. Everything looks good there. So setup 1 and 3 are done. Now we're going to rotate the part away from us, and we're going to set that as our origin for the second setup. You can duplicate this and set this as your default folder. Rename this. I'm going to rename it to setup 2 and 4. And then we can set up the work coordinate system. So the new work coordinate system is here, and the z-axis is vertical to this face, or perpendicular to that face. So now that we're done, there's some drilling, just different geometry, so I can clear the old geometry, select the new geometry. It keeps the same depths and everything that I had from the previous setup since I just copied it. So that's good. Now we have things that are different because we have this end cut that's different, and then we have this. A couple of things that you can do with the end cut that I often do is I create a little sketch. We can create under design, or I'm sorry, under 3D model, I can go start sketch. create a sketch here and create a line for me to follow on the end cut, because there isn't one. Might need to project a little geometry here. And then I can create a line from this, it should snap in there to that point there. And then when I do the end cut, I can just select Alt, select the line there. And that gives me a nice cut there. Okay, the other way that you could do this is, since we really need to cut through the middle and we need those little fillets, if you want to do it like this, let me show you an alternate approach that might be a little bit easier. So instead of just doing that, let me go to the Cam tab, and I'm just going to duplicate or copy all of this so I don't have to set all the depths and everything. I'm just going to select a different geometry. That, not copy, copy. Interesting. Okay, struggling here. See if I can copy this old one and see if I can paste it. I Control V and Control C this one up here. Basically, an alternate approach would be under your geometry, would be to select, let me get rid of the sketch. Right here. Because I want to basically select this edge and then this edge and then here and here. Let me show you that. Go back to the Cam tab. So we can select this, basically those edges here. And then hit OK. And you notice what we're getting here. We're getting the end cut settings where we're not diving into material. We're going half the speed. We're cutting in, and then we're doing the same thing on the opposite side. One thing to be aware of, if we're ever cutting on this end, we need to make sure that our stopper isn't near the top or we're going to cut into it. So instead of using the end cut like I did here, which you could still do, I'm just going to use this one because it does both sides and it avoids me even having to make that sketch. Not saying that the sketch option is wrong, it just doesn't do the little filleted corners that I would like. Okay, so I'm actually just going to delete that middle contour there. Now, what's left is cutting this thing apart. And to do that, I'm just going to do another contour. And in fact, I'm just going to copy this because a lot of the settings are the same, like my half the speed since I'm doing a slot cut and all of that. But I'm going to delete the geometry. And now I'm going to just do Alt left click like that. And I'm going to basically do a full length cut, but I want some tabs in there. And so I'm going to create tabs. And by default, it gives me these rectangular tabs. I actually prefer the triangular ones just because it's a little easier on the end mill since it's not diving vertically down into material when it's doing it. What's misleading about the tabs is the height, because it says 0.0625. But if you recall, I went deeper than the material by 25 thousandths. So it's actually 25 thousandths less than that is my tab height, because notice it's giving this full. So I really don't have a full 16th of an inch. I went 25 thou deeper. If I went 0.075, that means I have 50 thou tabs. It's those might be a little too thick. Maybe they're a little too thin. I'm just going to change a couple things up. I'm going to make the tabs a little bit wider. That gives a little bit more material here. And then I'm just going to change the spacing to 1.5 inches. Give me a few more tabs. It's hard to know. Realize we don't want to cut through all of the material because then it won't hold in the vise when we do the opposite side. But we don't want to leave so much material that it takes hours to clean up at the end. So it's kind of a little trial and error thing, but I think leaving 50 thousandths of an inch thick tabs at 1.5 inch spacing should be a good balance. Um, Other than that, I already have my depth set and I have my speeds halved, and I do have the linear lead-in distance. One thing that I'm going to do is just increase the linear lead-in distance, and let me just hit OK without changing it and do that and explain why. Notice I'm still going to be diving into material, and that's because I selected the edge starting at the end of the fillet. So I just want to extend that linear lead-in distance here to maybe 0.25 or something. And then we can visually look at it. Ooh, clicked the wrong button there. Visually look at it to see that we are indeed not diving into any material when we do the simulation. Um, and so when we play, we're fine there. Okay, so the nice thing about this symmetry of this part is I really am done because operation 4 is the same as operation 2, and operation 3 is the same as operation 1.